Okay, in this video, I'm going to show you how to solve 0 or 1 knapsack problem using greedy algorithm and lexicographic method. So let's start with an example. A game has a shop with various items. Each item has 5 information attributes, namely ID, price, power stats, health stats, and speed stats. We, as players, want to buy all the items available as long as our money is still available, where we have priority to buy items that maximizes power stat first, then health, and finally speed stats. So we have this list of items. I created this in a nested list where the first element is the ID, the second is the price, the third is the power stats, the fourth is the health stats, and the fifth element is the speed stats, right? And then we have our available money, right? So what is 0 or 1 knapsack problem? So this is a problem where you are given a set of items, each with a weight and a value, and a knapsack, which is a bag with a maximum weight capacity. So a weight is actually the price, and a value is actually the stats, right? The goal is to determine the most valuable combination of items to include in the knapsack without exceeding the weight capacity. So the weight capacity is our available money. Each item can either be included or excluded, hence 0 or 1. And in this video, I'm going to show you how to solve this problem using greedy algorithms. So the method I'm going to using is called lexicographic method. So this is a method where multiple criteria are considered in a prioritized order, right? So solutions are compared by evaluating the most important criterion first, which is in our case is power stats. If there is a tie in the power stats, the next criterion is considered, which is health stats, and so on. So the next or the last is the speed stats. And this method ensures that the highest priority objectives are satisfied first, right? Because we want to ensure that the power stats are maximized first because it is significantly more important for us, the players, right? So I'm going to use a greedy algorithm to solve this problem. This is an approach that makes the most optimal choice at each step, aiming for locally optimal solution in the hope that it leads to global optimal solution, right? It works building up solution piece by piece and always selecting the next piece that offers the most immediate benefit. But you need to remember that while simple and efficient, greedy algorithms do not always guarantee the best overall solution, right? But yeah, this algorithm is actually quite easy. So let's see how we implement this. The first thing we need to do is to sort the items, right? We have two options. First option is sort the items only by value points, of course in descending order. So we want to maximize the power stats, and then the health stats, and then the speed stats, right? We sort this in descending order, reverse through, which is mean descending order. Or we can use the option number 2, which is sort items by value or price ratio in descending order. So not only we sort this by value points, we sort this by ratio. So we see that x2, index number 2, is the power stats ratio to price, right? Power to price ratio, and then this is health to price ratio, and then this is speed to price ratio, right? Of course that option 2 is better, and we'll see that why. So first we initialize variables to store the solution, right? So we have like 3 variables. First is the selected items, which is a list, and then the second is the total value to store the stats, our three stats, and then the remaining money, which is starting with our available money, right? And then we select items greedily based on the highest value per price ratio. So this is using for loop. I say for item in items, we just have 5 attributes, right? Item ID, price, power, health, and speed. And we check if the price is lower or the same as our remaining money, right? If this is true, then we select that item, right? So we append this to our selected item list. And then if we choose that item, we get our power stat, our health stat, and our speed stats, right? So this goes to total value. And then of course our money is deducted by that item's price, right? Okay, so if we run this, let's say start with option 1, right? Then I'm gonna print item sort by, first is by value, by value, and then selected item using greedy algorithm and the total value that we get, right? So this is the item sorted by value, right? The top one is of course item number 8, which have 45 stat points for power, right? And the selected items using the grid algorithm are item number 8, number 7, and number 5, right? And we get the total value right here. So 115 for power, right? Let's save this. And let's see. We try option number 2, right? Which is actually, it is better to use option number 2. So we run this, and then we run this, and then we get different results, right? So now the top item is actually item number 9. Why? Because it is sorted by the ratio between power stats and price stats. Because if you look at the ratio, of course, item number 9 is actually have the most, have better ratio, bigger ratio than item number 8 or number 7 or number 3, right? That's why the selected items is also different, right? Sorry, this is item sorted by ratio, right? Okay, and we get actually better results, right? We get power points, which is 125, better than the previous sorting method, right? So that's it, how you implement a greedy algorithm to solve 0 or 1 knapsack problem, also by using lexicographic method. Thank you very much.